Hello everyone, welcome back. Today we are going to explore a very important topic in data analytics, which is probabilistic classification. I'm Priyadashni, Assistant Professor in the Department of CAC in SNS College of Technology. Let us understand how the uncertainty in prediction helps us making smarter decisions. Okay. In traditional classification, the model gives us only one output like spam or not spam. Okay, but real life decision usually aren't that simple. Probabilistic classification goes one step ahead. It doesn't just say what the classification is, but tells us how confident the model is. For example, instead of saying this email is spam or not spam, we can expect the system to say us this is 85% of the mail is spam and 15% is not spam. Okay, this probability is extremely valuable because it helps us assess risk, uncertainty and confidence behind every prediction. Let's take the medical diagnosis example. If tumor is predicted 95% malignant, doctor may choose immediate surgery. If it shows 55% malignant, they may go for additional test and monitoring instead. So probabilities helps in graded decision making, not just yes or no outcomes. This is why probabilistic classification is essential in high risk states, fields like health, finance and safety. There are two fundamental approaches, a way of performing probabilistic classification. First is discriminative model and second one is generative model. These in discriminative model, these directly estimate the probability of cases, class given features. Example, logistic regression, support vector machine. In generative model, these models how the data is generated, feature or class or probability of class, then they apply Bayes rule. Example, Bayes Gaussian mixture model. Generative model can simulate data while discriminative model usually give higher accuracy for classification. Here is the Bayes, which is the most popular generative classifier. Its key assumption is that features are independent given the class label. This assumption makes the model extremely fast and surprisingly effective. Where do we use it? In spam detection and in sentiment analysis, in text classification, even simple games like predicting whether to play tennis based on weather condition, because it works well with high dimensional data. It is very common in text analysis. Here is the evaluating probabilistic classifiers. When we evaluate probabilistic model, accuracy is not enough, especially for imbalanced data set. For example, a model that predicts non-tumor for every patient gets 99.9% accuracy, but it's useless. So we go better metrics. It is called as precision, called F-score. Precision is nothing but how many predicted positive or correct. Recall how many actual positives were found. They are crucial for rare, but it is important class. F-score is this balance, precision and recall using a harmonic means. Here is the advantage of matrices. To evaluate the quality of probabilities, we use log loss and Bayes score. Lower log loss means better probability estimation. Bayes score measure the mean squared error of predicted probability, tells us how calibrated the model is, and these matrices go beyond labels. They check if the probabilities truly reflects the reality. Next is from the probabilities to decision. Just predicting the probability is not enough. We must convert them into decision. There are three key steps. First one is thresholding, second one calibration, third one is application. We can just adjust the decision threshold based on the situation. A higher threshold increases precision, a lower threshold increases recall. Calibration ensure that if the model predicts 70% probability, the actual outcome happens about 70% of the time. And third one is application. Well calibrated probabilities improves trust, especially in domains like healthcare and finance. Here we have the overall summary to summarize. Probabilistic classification helps us understand uncertainty. We have two model types, discriminative and generative. Naive-Bayes logistic regression, SVM or key algorithms. Evaluation needs special matrices like precision, recall, log loss and Bayes score. These methods are used in medical diagnosis, spam filtering and sentiment analysis. Understanding probabilities lead to better, safe and smarter decision. Here we have two questions. Which metric best evaluate the probability quality is nothing, we know that, log loss. What is the key assumption of naive-Bayes? To feature independence given class. Hope you understand this concept.